Simultaneous equations with linear and quadratics. So whenever we solve simultaneous equations, what we're actually trying to find is the point of intersection. And here we're going to look at doing it with one equation being linear and one equation being a quadratic. Let's jump straight into it. Let's look at y equals x minus 2, which is our linear equation, and y equals x squared minus x minus 2 being our quadratic equation. Now to solve them simultaneously, we know y equals all of this and y equals all of this, so this must equal this if they're both equal to y. So let's start with that step. So x minus 2 would have to equal x squared minus x minus 2. And let's take everything to the right hand side. So we're going to subtract x from both sides. So we'll get a minus 2x, and then we're going to add 2 to both sides, which will cancel out with the other 2. Now we just have to solve this equation for x, which is a quadratic equation. So we can factorize out an x, so we get x minus 2. And solving this equation for x can either be 0 or 2. So they're going to be the x coordinates of the point of intersection, but we need to go ahead and find the y coordinates. So we can pick any equation to do this. We'll pick the linear equation because that'll make things easy. So when x is equal to 0 and when x equals 2, we'll do that after. So when x equals 0, we have y equals 0 minus 2. This is subbing it into this equation here. And we get y equals minus 2. And when x equals 2, let's go ahead and sub that one in. So we get y equals 2 minus 2. So we get y is equal to 0. And our final answer is going to be the point. We're going to have 2 points of intersection. So when x equals 0, y equaled minus 2. And when x equaled 2, y was equal to 0. And if we were to do this graphically, what we'd actually have is we'd have our parabola that had a y-intercept of minus 2 and an x-intercept here of 2. And we'd have our straight line going through minus 2 and 2. And you can see they intersected here and here, with this point over here being 2, 0, which was one of our answers, and this point over here being 0 minus 2, which was the other answer. So graphically, that's what's actually happening. It's this quadratic and this linear intersecting twice to give us 2 answers. So it is possible that a linear equation could have been something like this, where it didn't intersect the parabola, and we'd actually get no solutions. Or it could even touch the parabola only once, and we'd only get one solution, so it'd have to be a tangent for that to happen. It's meant to be touching, and we'd only get one solution there.